If you've chosen grid tie as your option, that's a great selection if you just want to reduce your bill and keep things simple and low cost. Now, if you've watched all of the chapters before this, you've got a great basis for what you're going to learn in this chapter. But also, look in the back of the box, you'll see which chapters are most pertinent to grid tie. We are going to focus in on the microinverter technology. That's the newest cutting-edge technology. There is no reason not to go with it, and it really improves the entire picture with grid tie. So let's start learning. When you're designing your grid tie electrical system, you might be coming at it from 3 different approaches. 1, where you do have a financial budget limit, a budget ceiling. Or 2, where you want to totally eliminate the electric bill, no matter what the cost. Or 3, where you're offsetting the electric use of certain items. Say you have an electric car and you want to make up that electricity with a grid tie system. Since you have to do this first, let's take a look at these 3. With a limited budget, multiply your total after rebate budget, remember you get 30% back from the feds, by about 70% to get the money available for panels and inverters themselves. Now 20% of your budget is going to go to rail mounts, professional rail mounts if you use professional rail mounts, and 10% about to an electrician. So go out and get the best price you can on panels and inverters, get them as a combo, and divide that into your 70% of your budget. So here's an example, $7,500 net budget, 70% of that would be $5,250. A 250 watt panel and inverter right now are about $400 total delivered, so you can afford about 13 panels, and that's 3,280 watts. Leaves you $1,500 for professional mounts and about $750 for the electrician. So you see, if you get the best deal on the electrician and mounts, that can leave you more money for your panels. So get your best deal all the way around and try to maximize the amount of panels you can afford. And then there's unlimited budget. You want to make all of your power. So get your average monthly kilowatt hour power use and multiply by 7. This is your total panel array power needed in watts. That's if you have 5 hours a day of sun average or better. Find the best deal on panels and microinverters that you can with the trunk cable that you're going to need, a package deal, and find an electrician who does solar and is licensed. That would be a NABCEP license. Then find an installation crew who's also qualified. He'll probably know one. Do some or most of the work installing the panels if you want to. But if you have a truly unlimited budget, go ahead and get several solar installers to give you their best bid and pick the best one. And third, there's displacing the power used by certain items, like an electric car. Find out how many kilowatt hours these items are using each month. Multiply that by 7 if you have 5 hours of sun a day. And this is your total array wattage needed again. Find the best prices on the equipment. Find a solar electrician and install crew. Do some or most of the work yourself. And both the microinverter and mounting rails do come with manuals. Know this. So if you are doing some of the or most of the work yourself, those manuals are excellent, and this is really simple technology. Or, of course, go and get bids from several pro installers and pick the best one. I do want to first talk about also the difference between using microinverters or one central inverter, as we use in the battery-based systems, the central inverter. Microinverters are the newest technology, cutting-edge technology that really improves a lot of things. One microinverter is connected to each panel. Each panel gets its own microinverter, and those microinverters optimize the output from each panel separately. That's very important, and that's what really makes them different. They can send output data to the internet for viewing. That means all the information about what the power of the panel is coming out during the day and the time and everything can be sent to a website where you can view it. And they also eliminate the problem of single panel shading. If you have a string of panels out there in series feeding into a central inverter, if one of them gets shaded, it can cut down on the power from the entire string. It's like the old Christmas light principle. If one bulb goes out, it kills the string. Well, this is not the case with the microinverters. One panel could be getting partially shaded, but it doesn't kill the power from the rest of the panels, which are in the sun. An excellent feature. And know that they're also priced competitively with using one central inverter box. Of course, they want to do that because they want you to use the microinverters. So that's why we're focusing in on them here. Let's take a look at the basic difference in using one central inverter and microinverters. On the top is your typical central inverter type of grid tie setup, and we'll have a bunch of panels generally in series adding up their voltage to a certain maximum number on that string feeding into the central inverter. And then we might have multiple strings, clones of that lineup, going into the central inverter. And those number of panels on a string and the number of strings that that inverter can handle, total wattage, will be in the specifications of that inverter. And then it goes to a circuit breaker and meter and connects up to the telephone pole grid. On the microinverter on the bottom, you can see that each panel has its own microinverter, and those all click into a trunk line that's on the bottom that strings around the panels. And then that trunk line at the end connects into a circuit breaker or a disconnect and then goes into the meter and the telephone line power grid. So as you see, it's a distributed method of having the inverter out there, one central or distributed, and the distributed gives us those tremendous advantages. Note that on the bottom with the microinverters, there's a maximum number of panel and inverter combos that can go on that single trunk line. With the one we're using, it's about 17. So if you're going to make more than 17 panels on your system, you'd use several trunk lines and strings of microinverters and panels. Let's take a look at the process of installing a typical microinverter grid tie setup. We're looking at the professional aluminum rail type of installation for grid tie here, and you can see we're mounting the microinverters right onto the rails. Let's take a closer look at the mounts and the microinverters. So Dan, what's the basic difference in the type of mounts that you've been using here?
This type here is called the PV quick mount, and personally I think it's exceptional. It goes in very easily and provides a very good seal on the roof to prevent any leaking.
And this punctures through the rafter underneath, so you get a good solid mount.
That's correct. You drill into the rafter and screw into it with a big lag screw.
And it's weatherproof, of course.
Yes, it is.
Let's take a look at the other type.
This type here is your standard standoff type of mount. It's actually a two-piece mount where you have in my case, a 2.5-inch standoff platform that attaches with 2 lag screws into the rafter. And then you seal the standoff by installing this standard roof flashing over the top of it.
Yeah, it looks like a regular roof flashing for a vent pipe.
That's exactly what it is.
Interesting. So you started with these and then you went to the other type? You like them better?
That's correct. I like the quick mounts much better. They provide what I think is a much a better quality seal on the roof, and they're also much faster to install.
I see.
With these type of standoffs, you're looking at putting in 2 lag screws, whereas with the quick mount, you only have to do 1. In addition, with this flashing, you have to work it back up underneath the shingles and really kind of work to attach everything afterwards, whereas with the quick mount you have to go under the shingles as well, but you don't have to nail down anything.
So you can see with the PV quick mount over here that its flange, or its piece of metal on the bottom, just slips underneath the upper piece of comp up there, and that gives it sort of water seal, and then you make sure that you know where your roof rafters are so you can bolt this right through, and then this U-bracket bolts on top of this block right here. This actually is free to move back and forth, and the whole rail will move back and forth until you mount your panels on it and cinch it all up tight. Here's an interesting and novel way of finding out where your roof rafters are. These are neodymium cube magnets that I bought off of eBay. They're very strong. Well, you go underneath on the roof rafter and duct tape it right on the side of the roof rafter. Then take one of the cubes and you'll know approximately where that rafter is. Go outside on the roof and this will easily pull onto the other magnet that you have taped onto the side of the rafter. And you'll know exactly where that rafter is. You can mark out a few of them and you'll get your rafter orientation. Now let's take a look at how we actually mount the microinverters to the rails, which are attached to the roof. Each microinverter bolts on with a separate bolt up here that slides into the rail itself. So when you're setting up your rails and you're ready to mount your microinverters on, you actually have to put your bolts slid into the channel, and approximately where this is going to go, you can mark these with a piece of with a pencil or something like that. Now the trunk cable that all of this attaches to goes alongside of the rail right here, and these little plastic clips, you can get these plastic clips and that holds the cable, and then we use extra tie wraps to sort of hold things in place. The plug from the microinverter snaps right into the trunking cable here and has a nice watertight seal. The MC4 connectors are right here and ready to snap into your panel. You do want to be sure that this whole arrangement is somewhere under the panel. It's not critical that it's right in the center, but there's a good amount of coverage to the left and right just to keep the water off of it. Here's our bare copper grounding wire that we're going to run between the microinverters to ground this all together. Let's take a look at how we attach that. The microinverter has a nice flange on the top that mounts to the rail, and you can see that you slip the bolt into the rail itself and then slip the microinverter over the little nut and cinch it tight. Now right under that is a little mounting place that has a Phillips head screw on it and 2 little notches in it. This is where we're going to slip our ground wire in and connect all of these microinverters together using that same mounting point to unify the grounding all the way down. You can see to the right of the trunk line and a connecting module that there's a little clip that goes into the rail, and these are sold separately and with the rail manufacturer, and these sort of hold the cable right over there as well. We use these tie wraps over here, and you can use these liberally along the way to dress your cables out underneath the panels. Sometimes the cable from the microinverter will have to go underneath it to get over and snap into the main trunk line. And sometimes it's on the same side as the trunk line, so you just have a little loop of extra cable there. Now when you set your rails up and you're ready to bring your panels up, remember to slide in your bolts and nuts into position, not exact position, rough position, so that you get up here and they'll be ready to rock and slid into the exact position when you're mounting your panels. On these type of mounting bolts, we have a little ground tab on the bottom that sits underneath the edge of both panels in the center of them, and that's what really makes the good ground contact between the panels when you cinch down this from the top. There's our number 8 bare copper grounding wire, and you can see it's cinched under the little grounding nut on the microinverter, and it just goes down the line to the next one. Here's our stack of 26 panels still in the box. We're using sharp 235 watt on this installation. So what we did, knowing that we needed a 62-inch spacing from here to here, was to go ahead and measure that out before we put the panels on, and then go ahead and get the rods somewhat perpendicular to the roof, and then tighten them at the bases over here. Not fully, but just about completely tight. Then we put the panels on, put the end clips on over here to hold the panel in, and then put our second panel in, and took a look. How is it mating flush up to the top of the rail? Is it nice and flat where it's really making good contact? And we jockeyed these rail holders just a little bit one way or the other to get them to mate perfectly flush up against the panels, and then cinched everything down, and then tightened the bolts at the bottom all the way down on the rail mounting bases. Now sometimes on your runs, you'll actually be splitting the run up physically between 2 different places. In this case over here, what we did was, since it was electrically one run, we just ran the cable and grounding wire between them, jumped it right underneath under there, and went to the next row of 2 panels over here. This is the way this roof went together. This is our connection point on those trunking cables that you're going to need to wire up your array. Remember when you're ordering this to go ahead and order the portrait or landscape version. The connectors are spaced out such that you mount the panels vertically or horizontally. Correct spacing to get between the panels. Most people are using portrait. And then of course when you get to the end of this cable, where it's going to land up here, you're going to have your 240 out. That's going to include the ground and the 2 hots and an extra cable. Here are the 2 most popular ways that 240 AC output line is going to connect up to the main power grid. On the top, we see that the photovoltaic array is going to come into a brand new circuit breaker box that's going to be installed by your electrician. And this will allow the circuits to be protected. Each one of the breakers can go to a separate run on the array, and then that also provides the ability to turn off and disconnect from the system. Then it will go to a meter, and this meter is provided by the energy company many times, sometimes not, and it can show you digitally what your usage is and what you are generating. It cycles through these readings in a course of about 30 seconds or so. And this is a typical one of these that we see these days. Now, on the second way it can connect is that the PV array is going to wire directly into your existing circuit breaker box by adding a couple of new breakers. Now, this provides the same circuit protection, and it also provides the ability to shut off the array. And then it will go to the meter, possibly a new one by the energy company installed, and then that, of course, connects up to the main power lines on the telephone pole. When it comes to installing the panels on the rails, that's the fun part, because the bolt slips right into the channel on the top of the rail and spaces the 2 panels out perfectly, and then pinches them down and holds them together between each panel. You're not actually using the holes that are pre-drilled in the panels to mount the panels. We're not going to tighten them down fully until we get to the end, take a look that everything really is fitting correctly, and then cinch them down. Remember, National Electric Code is going to mean that you have to have an electrician to make sure that you're complying with it. That's why we have to do this with grid tie. Remember, this is not that complicated though, so take your time and get everything exactly correct. It's going to go rather quickly. Now I'd like to mention the idea of a hybrid grid tie system. Because of islanding, where your system must disconnect from the mains during a power outage, you'll still need a generator or batteries to have power 24/7. So your grid tie system can incorporate a generator or a smaller battery bank to provide power in these conditions. A switchover relay system is used to automatically use the generator or the batteries if AC mains power is lost, and this configuration is slightly different depending on which type of inverters you're using. If this is interesting to you, ask your electrician about the options you have on this. So let's step through the grid tie system installation process. First thing is to find a NABCEP certified electrician to work with. That's the solar certification. And then decide how much, if any, work you are going to do yourself. The more work you do, the quicker the payback time. 3, figure out how big a system you're going to build, depending on what we discussed. Then file your net metering agreement with your power company. This is the form with all the specifics on it. Then have the electrician pull the permits, especially if you're in the city limits, you've got specific permits to have pulled. Then set up a building and installation schedule with your installer and order all the parts from the best sources you can find, get the best prices, execute the installation, and then get your inspections for the permits that were pulled to see if you're compliant. And then have your final inspection from the electric power company. That'll be the last one. Throw the main switch and kick back and have a cool iced tea. Or if you've got the money, find the best price on the system from a professional company and have them execute the installation. Well, there you go, the basics of microinverter-based grid tie solar power systems. So find yourself a friendly electrician, because he or she is going to have to pull the permits if you're in the city limits. If you're out of the city limits, maybe not. And then make the final connections with the circuit breaker disconnect and the meter. Most likely they're going to put in a new meter for you from the energy company, and remember, you're going to have to file that net metering agreement with the energy company giving the specifications and design of your system. Best of luck.